Okay guys, so let's get on to today's lesson. So if you have managed to log in today, you'll reach this page again. So let's create a new circuit to start on today's lesson using the ultrasonic sensor. Alright, so you should have all this clear plate here. So as usual, we're gonna start with our Arduino, and of course we're gonna also use a breadboard. Okay, so okay, I'm gonna make it a little bit smaller. I can just choose Control minus to make it a bit smaller so that you can see the whole setup. Okay, so what I'm gonna do now is I am going to find my ultrasonic sensor. Okay, so this is my ultrasonic distance sensor. So what we're going to do is I am going to put it here. So let's just say my ultrasonic sensor. Okay, what I'm going to do is I'm going to turn it so it's easy for me to align it later on. Okay. Of course, if I'm not going to use any other things with my ultrasonic sensor, I don't even need a breadboard. I can link it directly to my Arduino, but because I want to make some modifications later. But let's start with the basics first. Let's see how we can get this ultrasonic sensor to work. So I am going to use my breadboard. So what I'm going to do is I am going to set up my 5 volt and my ground first. Okay, so let's use my ground. Okay, alright, so of course I can make it a bit nicer, and of course I want to change my colors to reflect. Usually ground is black, and for my 5 volt, anything to do with our VCC or power, I will use red. Okay, and then from here what I'm going to do is I am going to connect. You can see, unlike the ultrasonic sensor, the real one that we saw earlier on the picture, our ultrasonic sensor here has only 5 volt ground and our pin. Okay, and this our signal pin actually covers both our echo and our transmitter. Okay, the transmitting out and the receiving echo pin. Okay, the receiver. So what I'm going to do is I'm just going to use to connect to my ground first. Okay, I will change this to black later on. Okay, for my ground, and then for my 5 volt, I'm just going to connect it to my positive. Okay, so for my signal here, okay, the ones that are going to be reading later on, what I'm going to do is I am going to connect this to my pin 7. Okay, my digital pin 7. So let's choose a different color for it. I'm going to use green. Okay, so this is my main thing. I just need to connect one pin to my Arduino digital pin, and the rest is just actually our power and our ground. Okay, so let's start with the coding now. Okay, so same thing, I am going to move this a little bit. Okay, so you can see more of my coding. Okay, so some of the students says, I'm serious, I cannot see. Okay, don't worry about it. Okay, I'll try to. Okay, so what should we do now first? Okay, first thing first, we need to create a variable. So we can actually measure in cm or inches depending how you want to do it. So I'm just going to use centimeters. Okay, so let's call this centimeter to measure distance in centimeter. And you can see I already have this, so I'm going to set our variable. Okay, so when when what I'm going to do is I'm going to see set an input. So if I go to my purple color here, input, you can see I have this thing called a read ultra sensor. It's a very long one. Okay, so what I'm going to do is I am going to oops, sorry, over here. Okay, I'm going to make it smaller a bit. Okay, so that we have more space for you to see. Oh, sorry, this the zoom out a bit. Okay, so what I'm going to do is I am going to, you can see here, read ultrasonic sensor on trigger pin. Just earlier on we have put our trigger pin on digital pin 7, so I'm just going to change this to digital pin 7, and that's it. I don't have to change anything else, and I'm just going to put it here. So what we're going to do is whatever distance that they have shown, they have used received from the ultrasonic sensor, any of the measurements, we are going to set it as the distance in centimeters. Okay, so what we're going to do is we are going to see, we're going to use our serial print, okay, in order to go and see what values we are receiving. Okay, so I'm going to take my previous serial print monitor here, and I am going to go to variable first, and so whatever values that have been set to centimeters, I'm going to put it here. Okay, but later on if I'm gonna look at it, I am okay, so I'm not going to put any new line first. I'm going to take another one because I want to know, because sometimes when we do the distancing, the measurements could be in inches or centimeters, okay, depending on how you program it. So I want to let other people look at my code, they will know that this is actually in centimeters. So I'm going to put another print. Okay, first line without a new line, that means it will just remain the same line, but when I put the unit behind the number, and then I will put a new line. Okay, so okay, so that's it. Actually, that's the main code that I need. So let's see how this thing works. Okay, we are going to try it out, and by looking at the serial monitor later on. Okay, so what I'm going to do is I am going to just switch on the serial monitor, and I am going to remove the code here. Oh, so but I can't see the serial monitor. Okay, so what I'm going to do is I'm going to start the simulation here. Okay, you can see the reading here is how do I, okay, let me just move this a little bit so that you can see how I actually test. Okay, let's start the simulation again. So how do I know how far is the object? What you can do is when you go to your ultrasonic sensor, you can just click it and you can see, oh, I have this object here, I can move near or far. So if I move it away, see, as I'm moving away, the reading here is showing on the serial monitor what's my reading. So what if I move my object nearer? Okay, and the reading is being here. Okay, so you can see this is actually the scope. Okay, hold on, let me go and zoom this out a bit so that it's easier for you to see the distance. I'm gonna move this a little bit again, so you can see this is the maximum 400. Okay, or not even 400. Okay, let's see whether you can detect. So once it's outside, so over here our maximum distance that they put is only up to 320. Yep. Okay, so that's it. That's how our ultrasonic sensor works. Okay, so let's start the simulation for a while. So let's think about all the different things that you can use, okay, for our ultrasonic sensor. Some of you might be asking, I'm serious, the distance is so short, 300 centimeters is only about 3 meters. What can I do with a sensor that detects 3 meters? Okay, because most of the time we use Arduino as a prototype. So if you want to use things to make, like if I can detect objects that are 3 meters away, I can use ultrasonic sensor. Okay, like I can make a simple radar, sonar actually, because it uses sound. Okay, and to detect things that are away from you and find out how far they are from you. Okay, and I can also use ultrasonic sensors to be part of a vehicle, like some of you have worked on the M boards before. Okay, you can see there's an ultrasonic sensor on the M board. to help detect objects so that the robot can change direction to avoid the objects. Okay, but what if I want to use something that detects at least like 100 meters away or even 50 meters away? Okay, so actually there are other sensors that you can get out there that can detect a much further distance, either through sound or even through some infrared. Okay, but these sensors are quite expensive, so we are just using these sensors now, the ultrasonic sensor, in the classroom. Okay, but if let's say you have some projects that really require for you to use a better sensor, let's say you want to make a warning to avoid things while you're on a bicycle, or whether you are on a vehicle maybe, all right, like some of the IBP program students have done, then we can use and go and get those better sensors. Okay, but for now we're just going to use this. Okay, but on its own it's not very useful, because when I'm too near, there are no changes in anything, or there's no warning sign. So let's make a simple let's use this ultrasonic sensor to make a simple warning system. Okay, that what it does is that it helps you to, let's say your car reversing. Every time you can see now there's a car when they're reversing, there's a sensor there, right, that tells you whether you're too near to the wall or to the curb, right? Okay, and then the driver will know when to stop before it hits while it's reversing. All right, so let's do something like that. Okay, so we are gonna modify this a little bit. All right, so I'm gonna just shift this a little bit in. Okay, so what I'm going to do now is, let me hide this code first. Okay, what I'm going to do now is I am going to use this thing called a piezo buzzer. Basically, it's just a small speaker. Okay, and I am going to also use a resistor that you're very familiar with. Alright. Okay, so this resistor, I'm just going to use the default 1 kilo ohm. Okay, I'll just say resistor. Okay. And I am going to also use my piezo. This is my piezo speaker buzzer, sorry. It's like a speaker, like a mini speaker. So what I'm doing is I am going to rotate my speaker. So I'm going to put it this way. Okay, I'm going to make this a little bit bigger so you all can see where I place them. Okay, so I'm going to put my buzzer here. Okay, you can see that it's straddling the middle part of my breadboard. One is on this side and one is on the other side. And I'm going to put my resistor over here. Okay, one leg is on the terminal 2, which is on the ground, and the other leg is connected to the this positive part of my piezo speaker. Okay, and so this negative is connected to this part of the piezo speaker, and on the other leg, what I'm going to do is I am going to connect it to my pin 8. Okay, so let's change this to blue maybe. Alright, easier to see. Okay, so if I were to make this a little bit bigger for you, so let's see what changes we have made. I put one resistor, which is a 1 kilo ohm resistor here, from the negative connection to this connection here on this one leg of my piezo. Doesn't matter whether it's positive or not. And then on the other leg, I am going to, of the piezo buzzer, I'm going to be connecting it to pin 8. Okay, so let's see how we can modify the codes now. Okay, so I'm going to make this a little bigger for you so that you are able to see. So let me just shift this a little bit. Okay, and I'm going to make the codes a little bit bigger. Okay, so you can see. So what are we going to do now? First, we are going to Okay, so first we are going to do a little bit of maths. Okay, we are going to use this block here. Okay, this symbol means it's less. Okay, this is lesser than, this is lesser than or equal to, this is equal, this is not equal, this means greater, and this is greater or equal to. Okay, so the first thing we're going to do is we are going to be using some measurements. If it's lesser than 150 cm, we are going to start buzzing. Okay, but if the distance gets even nearer to the wall, let's say it gets lower than 50 cm, then we are going to start to buzz even faster. Okay, so let's first use the first distance we're going to do. If it's lesser than 150 cm, we're going to start buzzing. If it's greater than 150 cm, then we will just nothing happens. Okay, so that means I got to do 2 of this, and the second one that I need to, sorry, I cannot make a duplicate. Okay, I can duplicate this and make a second one. So, but if the distance is still greater than 100, okay, greater or equal than 100 cm, then nothing will happen. Okay, so I will need to first use a control to check, and so we need to use our if or then else. Okay, but I need to have these 2 things here. So if it's lesser than 150 and is greater than 100, so if the distance between 100 and 150, I will start our buzzing of our buzzer. Okay, so I need to put both inside, but I have only 1 square, so I need to use one more. I need to find this block called n. Okay, n means I need this to be both at the same time to be correct. So if it's greater than 100 n, but n lesser than 150, so I'm going to take this whole block here and I'm going to put it inside. Okay, so if your distance from the wall, the sensor is reading that it is between 100 and 150, I will start buzzing. Okay, so how do I buzz? I will go to my output now, and let's see. Oh, play speaker on pin. Earlier on, we already put the speaker on pin 8. Okay, so I'm going to set pin 8, and this is up to you. You can put any number, but I'm going to use the buzzer, the sound of tone 57. Okay, you can look up on the internet all the different number tones, the numbers for different tones, and I'm going to put 0.8 seconds. Okay, okay, sorry, this must be 0.3 first, because later on you find out why. Okay, so I am going to put this inside. Okay, so let's check what we've done. If we'll check for the distance, if the distance is between 100 cm to 150 cm, then we'll start playing the sound on this piezo buzzer. Okay, so let's see if it works. So I'm going to reduce the size of my diagram by using Control minus. Okay, so that you can see when I am moving everything. Okay, so let's see now. Let's start now. If I start the simulation, and you can see at 200, it's just reading. If I were to move this, okay, so what happens when you get to less than 150? Okay, let's stop the simulation first. Okay, the sound. Okay, let's put in a little bit of wait time. Let's put, sorry, not here. Okay, let's put 1 second wait time here. Alright, so let me change this to maybe 0.5, and let's see whether the sound improves. Okay, okay, let's try now. See whether it's better. Okay, if it goes less than, it's reading. Yes, it's reading below here. It's moving. Okay, we got. Much better. Let's see what happens if I go below 100. Oh, below 100 it stops, because in our code we only put it for if this buzzing only occurs if it's between 100 and 150. Okay, so let's do a little bit of change of this code. Let's improve on it. We are going to now see if what happens if it gets lesser than 100. Then that means it's very near to the wall, so we want the buzzer to buzz even faster or louder, so that the driver will know that he has to stop. Okay, so let's make things simple. I want to use this again, but I am just going to duplicate so that I don't have to do it another time. So this is the first one. Okay, if it's nearer. Okay, and for the second one, okay, I am going to change if the distance is between 50 cm and 100 cm. Okay, if it's lesser than 100, I want the buzzer to be even faster. Okay, so earlier on, remember I put 0.8, so actually the 0.8 I need to set here, because this amount of time that you set is the amount of time that the buzzer remains on. Okay, so I will put back my wait of 5 seconds there. Okay, let's see what is happening, what changes we have made. Okay, so we have just added another block here. So if the distance now is between 50 and 100, then the buzzer will buzz very fast, okay, to inform the driver that you're too near to the wall and you need to stop. Okay, so let's see if this works. Okay, we are going to start our simulation now. Okay, let's move this out. Okay, so let's start here from 270. You can see the reading is reading in our serial monitor. Okay, so we're gonna go nearer to 150. Okay, what happens when we reach 150? Okay, it's buzzing. What happens when we get to below 100? Oh, the warning now becomes to tell the driver to. So when it gets nearer than 100, the buzzer becomes very loud, so the driver needs to stop the car. Okay, so maybe if we have other things that maybe some MP3s or what, we can even use it in the code to tell the driver to stop reversing. Alright, so let's test this once more time. Okay, if it's more than 100, 150, if nothing happens. Okay, but once we pass 150, our bus will start to buzz. And if I go below 100, okay, it informs your driver that it needs to stop. Okay, so I hope this has been interesting for you. Okay, so maybe you can think of any other applications that you can use this for. Okay, and there's a lot of other projects using our ultrasonic sensor that is even more cool, like making your own radar, but you need to use things like processing and all that. Okay, but when we have the time, we'll explore that and see how it goes. Alright, so give it a try, and if you have any problems, you can just let me know and the following week and see how I can help you out. Alright, so all the best, give it a go. Meanwhile, keep your feet on the ground and keep reaching for the stars. Alright, see ya.